Hello, and welcome to G Fun Facts Online. Today, we're looking to the stars, but not just at the stars we know. We're talking about a revolution in how we see the entire universe. Imagine a movie, not just any movie, but the greatest movie of all time. The cast? Billions of galaxies. The plot? The very evolution of the cosmos. The director? A brand new, groundbreaking observatory perched high in the Chilean Andes. This is the story of the Vera C Rubin Observatory, and it's about to premiere. After 2 long decades of planning and construction, this facility is ready to open its eyes and begin a monumental task, creating the most detailed cinematic map of the night sky ever produced. The excitement in the scientific community is palpable, rivaling the buzz we saw for the James Webb Space Telescope. And it's all happening for a very good reason. But first, let's talk about the name. The observatory is named in honor of a true pioneer, Vera C. Rubin. She was the astronomer whose groundbreaking work in the 1970s gave us the first real evidence for something we still don't fully understand: dark matter. She had a principle of questioning what we can see to understand what we can't. As she once said, "My life has been an interesting voyage. I became an astronomer because I could not imagine living on Earth and not trying to understand how the universe works." That spirit is the driving force behind this entire project. So what makes this observatory so special? At its core is the 8.4-meter Simony Survey telescope. Its unique 3-mirror design gives it a massive field of view, allowing it to scan the sky incredibly quickly. Attached to this beast is the largest digital camera ever built, the Legacy Survey of Space and Time Camera, or LSST camera for short. Get this, it's the size of a small car, weighs over 3 tons, and packs a staggering 3,200 megapixels. To display just one of its images at full resolution, you'd need 1,500 high-definition TV screens. With every single shot, it captures an area of the sky more than 40 times the size of the full moon. This incredible duo will carry out a 10-year mission called the Legacy Survey of Space and Time. The plan is to survey the entire southern sky over and over again, imaging it every few nights. This is what creates the movie. Rubin Observatory Chief Scientist Tony Tyson puts it perfectly: we're making a digital color motion picture of the universe. It will contain information that we can get in no other way. The amount of data will be staggering, about 20 terabytes every single night, adding up to a 500 petabyte dataset over the decade. The observatory is set to tackle 4 of the biggest questions in astrophysics. First, the nature of dark matter and dark energy. Here's a mind-bending fact. Everything we can see, all the stars, planets, and galaxies, makes up only 5% of the universe. The other 95% is a complete mystery. About 27% is dark matter, the invisible scaffolding that holds galaxies together. And 68% is dark energy, the strange force that's making the universe expand at an accelerating rate. The Rubin Observatory will map billions of galaxies and study how their light is bent by the gravity of dark matter, a process called weak gravitational lensing. This will give us the most precise map of dark matter ever created and help us understand the cosmic tug-of-war between it and dark energy. Second, taking a complete inventory of our solar system. Rubin's deep and frequent scans will revolutionize our understanding of our own cosmic backyard. It's expected to discover millions of new asteroids and comets. Crucially, this includes potentially hazardous asteroids larger than 140 meters. It's estimated Rubin could find up to 90% of them, giving us a much better watch on our neighborhood. This massive catalog will be like a fossil record of our solar system's birth, and might even help us finally find the elusive Planet 9. Third, mapping our own galaxy, the Milky Way. Much of our galaxy is hidden from us by clouds of gas and dust. Rubin will be able to peer through these clouds to catalog over 10 billion stars. By using special types of stars as standard candles to measure distances, it will map the structure of our galaxy's halo in stunning detail, creating a fossil record that could finally tell us how the Milky Way was born and how it grew over time. And fourth, Exploring the ever-changing, dynamic sky. The night sky isn't static. It's full of things that go bump, or rather, flash in the night. Rubin will be the ultimate cosmic sentinel, expected to issue up to 10 million alerts every single night. That's 10 million notifications to astronomers around the world about anything that moves, brightens, or changes. We're talking about exploding stars called supernovae, the violent collisions of neutron stars, and even the flickering of supermassive black holes. This real-time alert system means we can point other telescopes at these fleeting events and study them before they disappear forever. But as the observatory prepares for its grand debut in late 2025, it faces a very modern problem: satellite megaconstellations. The very things that make Rubin so powerful, its wide field of view and incredible sensitivity, also make it extremely vulnerable to the bright streaks left by low Earth orbit satellites. Scientists worry that as many as 40% of all images taken during the survey could be damaged by these streaks. As one research scientist said, it's unfortunate that this huge increase in the number of satellites is coinciding with the decade of Vera Rubin's operation. Efforts are underway to reduce the impact, but it highlights a new battle for the future of astronomy. Despite this challenge, the Vera C Rubin Observatory stands on the brink of history. The data it gathers will be open to scientists and the public, empowering a new generation of discovery. The greatest movie of all time is about to begin its 10-year run, and its premiere will change our view of the cosmos forever. That's all for today on Fun Facts Online. Thanks for listening, and don't forget to keep looking up.